Okay, so hello everyone. Thank you so much for joining for this study session with Ladies Be Architects. It's a pleasure to be here with you today. My name is Susannah Plaisted, and I'm an architect evangelist at Salesforce. And today we're going to be talking about a well-architected approach to packaging. So before we get started with the content, just wanted to talk a little bit about Ladies Be Architects very quickly. So Ladies Be Architects, or LBA, as I shorten and refer to it as, is a volunteer group with a goal and purpose of building confidence for all aspiring Salesforce architects, and of course, highlighting and amplifying women's voices in particular. And we are an inclusive group, however, and we encourage everyone of all gender identities to join us on our study sessions or any of the events that we have. So I am one of our co-leaders of Ladies Be Architects. You can see here on the screen our other co-leaders and our amazing ambassadors in the US, and of course our founder, Gemma Blizzard. And we all started, why we're all here today is that we were founded in 2017 by Gemma, back when 1 in 25 CTAs were women, and when there wasn't really a Salesforce architect community at all. So really all of this started with Gemma, and we are very thankful for her. And our initiative, so you're here this morning for a study session. And that's one of our initiatives. We have study groups that align to the different architect certifications. We also have spotlight series, and this is kind of a hybrid, honestly. It's talking a little bit about a topic on the exam, but it's not going to really focus specifically on how to pass the exam. It's more of a spotlight on how to build package strategies and why that's important. We also want to expand our mentoring initiatives and have some more solutioning sessions. And we're also a group for resource sharing. So definitely get on the community group in the Trailblazer community, or follow us on Twitter or LinkedIn, or just head to our website. That's where we host all of our content, tons of videos, lots of presentations. And we'd love to hear what sorts of initiatives you would like for us to pursue in the future. Okay, so now let's go ahead and dive in and talk about packaging. So why are we here? Why are we even talking about packaging in general? Why should you, as an architect or an aspiring architect, care about packaging at all? Well, one of the reasons I talked about study sessions, packaging is a part of the development lifecycle and deployment architect certification. These are the 2 bullets from the study guide I just pulled out today. How you should be thinking about packaging regarding the certification. So you should be able to describe the appropriate development model. So org-based or package-based development. And we're going to talk about what that means. So you should be able to identify when you should use which. And also you should be able to explain the use and considerations for the different packaging tools that we'll cover as well. So managed, unmanaged, and also unlocked packages. But I would say that that's not really why you should care about packaging, not just for the exam. Really why you should care about packaging is that this is one of the habits that's going to help you design more composable architectures. And composable architectures are built-in units that allow you to swap different pieces of your solution in and out of service. And this is important because it's going to help you improve the stability and the adaptability of the solutions that you're building on Salesforce. And so the benefits of packaging, really like sort of the TLDR, like why should you care? What are the benefits of adopting a package development model? Packages can help in 3 main areas. So they can increase stability when moving your metadata from org to org, or from like business to business. So if you're an ISV, if you're trying to move your changes to a customer that's bought your solution, you're going to do it with packaging. It's a very secure, very reliable way move that metadata around. It can also speed up development time, because when you use packages, you can really quickly spin up development environments for developers to get started. And also it supports, and we'll look at how some of the packaging models support what we'll refer to as parallel development models. So you're able to have multiple development teams working on a project or a feature at the same time, which can be really helpful. And then the third benefit of packaging is that it is going to bring predictability and control to your releases. So these are three main benefits of packaging. And I'll say a caveat here. So the caveat is packaging does take a specific skill set, and we'll cover exactly what that looks like. And being able to support a team that has a skill set that can define, maintain, and really develop effective packages can be tough. But I would say that the idea of achieving packageability in your solutions should be the ultimate goal for nearly every Salesforce org, even though it can be like something to strive for. It's not something you're going to wake up tomorrow and like immediately have this awesome packaging strategy in your org. It does take time. So we'll talk a little bit more about that too later. But to start, to like make sure we're all level set on the same page, I wanted to start by sort of sharing a definition of what exactly is a package. So at a very basic level, a package is a container for something as small as, in Salesforce terms, an individual component. So like a field or an object or an Apex class. So it can be as small as those individual components being in a package, and that maybe corresponds to this little popcorn container we have here. So it can be as small as these little popcorn pieces, or your package can be as large as an entire set of related applications that you've built in Salesforce. So that in the real world might translate to more of like a shipping container. It could be a series of shipping containers holding really large things. And what I like about sort of thinking about this in the abstract is that packages do a couple of things that I think these pictures kind of illustrate. They make it easier for you to move stuff. So like it's much easier to move your popcorn that you bought at the movie stand with a package rather than like trying to hold it in your hands. Also, it on the bottom, the other image that we have with imports and exports, packages are going to allow you to keep better track of the stuff that you are putting into that container. So like you might do that with the manifest in a shipping container scenario, or that like checklist of all the stuff that's in a package. So these are all benefits that come from using packaging. But again, at its core, it's just a container that holds stuff. It might be one thing, might be two things, might be like thousands of things. Okay, so now that we know sort of in theory what a package is, let's talk about specifically in Salesforce, what types of packages are there? So in Salesforce, there's the concept of what's called first generation packaging, or 1GP, and second generation packaging, or 2GP. And inside those two those are like two models of packaging. And obviously first generation packaging came a while ago. It's been around for a long time. And 2GP has been around for maybe about 3 years now. You can correct me if I'm wrong in the chat, or if you're watching this later in the video, but it's newer. It's not brand new, but it is newer. And there's a subset of tools that you can use, whether you're leveraging 1GP or 2GP. So the concept of managed packages, and that's, you all are probably familiar with managed packages from the App Exchange. So the managed packages are what ISVs develop and you install into your org from the App Exchange. So managed packages exist in 1GP and 2GP. And then for customers, you can also use packages as well. It's not just for ISVs. And in the 1GP model, customers could create, and I mean, customers and ISVs, frankly, can create unmanaged packages. And there are benefits of, and we're not going to talk too much about the 1GP, but at a high level, managed packages, right? They're created by ISVs. they're more locked down. So you can't necessarily change something in a managed package. You can't necessarily edit the code or even view the code in a managed package. And with unmanaged packages, like it kind of sounds, they're less structured. So you can see the metadata, you can edit it. And there's some other benefits and I guess risks that come along with each of those. But in second generation packaging, we also have the same concept of a managed package that an ISV would create and manage themselves and then distribute out to folks that purchase that package. And then we have the concept of unlocked packages, which can be used by customers or ISVs. And unlocked packages, kind of same concept. You're able to build them yourself as a customer. And you can swap things in and out. You can remove stuff from unlocked packages and you can deprecate them, but they are more used by customers along with ISVs as well. Customers aren't building managed packages. Okay, so that's the different subsets and sets of tools that exist for Salesforce specifically. But now a probably natural question you might be asking yourself is, well, okay, if those are what's available, like what should I be using if I'm interested in moving into this world of packaging? And I'm borrowing the slide from one of my colleagues, Vivek Chawla, who has an amazing deep dive on second generation packaging. The link is here on the slide that we'll share. But I think this slide does a really good job of illustrating sort of the differences between 1GP and 2GP, or at least how to choose. So to better illustrate this, we're gonna sort of visualize this old model of 1GP, which is also referred to as org-driven package development, because in this model, the Salesforce org is really at the center of all of this development. So there's a packaging org, that's where you like wrap up all the changes that you're going to deploy to your customers. It's the system of record for all the metadata, all those changes that you want to move around. And when you bundle up or package your metadata, you can create major or minor releases in what folks who are really into packaging refer to as 0-4Ts. So you'll hear them throw that around. Really, that's the ID of the package. So it's really saying you package your metadata and then it results in these 0-4Ts, or these actual things that you can install from the app exchange, for example. And it gets a little trickier when you want to, for instance, patch a 1GP package, because then you need to use another type of org called a patch org to do a patch release. So that's, you might do that if there's a bug that you need to fix that's between versions, that's already installed in a customer's org. And so again, this is an entirely different org over here, type of org. Your packaging org is a different org. And the sole purpose of all of this is just for building these different packages or containers for metadata. And over the lifetime of an app, you could imagine that you're going to have dozens, if not more, of these different types of orgs. Okay, so you can, in this 1GP model, again, we're still in 1GP, you can try to make sense of all of this metadata that's floating around in all these different orgs by storing it in a version control system. And if you are using 1GP right now and you're not doing this, you're not storing your metadata in a version control system, you definitely should if you're not doing that now. But throwing all of the metadata into a version control system like Git is not necessarily going to solve the problems that are inherent to using this org-driven package development model. And it doesn't make it what we're going to talk more about, which is source-driven development. It's still org-centric development. So that's why we are saying move away. I mean, you should, if you've read Well-Architected, which is available at architect.salesforce.com, a shameless plug. If you have read Well-Architected, you'll know that one of our recommendations is that you should be moving away from org-driven package development, because having these orgs in general as your source of truth for your metadata is very risky. It's really brittle. It's very easy to make a change to something in a Salesforce org, and it's not really traceable. So you can't really see who did it necessarily. Like we have our a setup audit trail and all that good stuff, but it's easy to change stuff. It's easy to break stuff, and it's hard to roll back changes, which is why the recommendation for a while now has been to use source-driven package development, which is that second generation package development. So in this case, instead of the org being at the center of everything, the version control system is at the center of everything. And instead of using a packaging org and the UI in Salesforce to package up your changes, you're going to use the Salesforce DX CLI to package up your changes. And you do that using a developer hub, which is an org. So there's still orgs in the mix, but that developer hub is connected to the CLI, and you can connect other sort of like scratch orgs or dev orgs, or what we see here is called like namespace orgs. This is sort of how you are, this is your accounting system for all of these second generation packages. And it helps Salesforce keep track of the packages you're creating. But at the end of the day, the version control system and the CLI are what actually builds the package. So they wrap up the metadata, and then again, they create these 04Ts or these packageable containers that you can install into your different orgs. And it's a little bit easier. So because you don't have to use this like crazy other package org to fix bugs and to upgrade things, it's actually much easier to patch things or to upgrade your packages in the 2GP structure. So that's one of the benefits, but there's actually another set of benefits, which is why we're definitely recommending using source-driven package development, or 2GP. So we're going to hit some of those highlights right now. So one of the benefits, which we saw on that slide of 2GP, is that you can use source-driven development, which is sort of the best practice, whether you're using packages or not. You should be moving towards a source-driven development approach. And with this, you don't require those different orgs or unique orgs for each package. The version control system, like a GitHub or Bitbucket, is that single source of truth for all your metadata. And then the advantage of this, above just having better stability, of course, and traceability with what's happening with your metadata, is also you can start to automate stuff. So packaging can be automated with a continuous integration tool like a Jenkins. So you can actually like automate the entire build and destruction of different environments, loading them with your packages, doing automated testing, and it can really speed up, like we said at the beginning, it can really speed up your development. Another benefit of this 2GP model, or second generation packaging, is you can do some pretty cool stuff with what's called package ancestry. So you can actually develop this flexibility, what we call flexible versioning. So if you go along, you have version 1.0 of your package, then you have a minor release that's maybe 1.1. And then you go off and you think you're okay, I'm going to build 1.2, and this is going to be this great new version that I'm going to develop. But maybe you realize that you made a change that you don't really like, and you actually want to revert back to that old package. You can actually say, okay, well, we're not going to have this linear model. We're going to instead go back a little back in time and say this 1.1 package is actually the one I want to build off of in the future. So it allows this flexible versioning. So you can sort of abandon, it's sort of like branching, right? You can abandon different packages if you've decided that that's not the direction you want to go anymore. So this makes this model, this flexible versioning model, makes your development process a little more agile and less fragile. You don't have to worry about like breaking that linear model. And then a third benefit is the concept of parallel development. So definitely related. With flexible package versioning, 2GP actually makes it easier for 2 or more development teams to build new features in parallel. So that's sort of what we're looking at right here. We can see that there's release 1.2.0. So it was a major release 1, minor release 2. And then there's 2 teams that are actually working on branches or different builds of the package, and they can go off and work in parallel. And team A can do one thing, team B can do another, and then they can merge their changes together in an integration branch or like a pre-release branch, and essentially promote the release up together once all of the different conflicts have been mitigated, they can merge their version up into that 1.3.0 release. So this comes with, this kind of comes with just the fact that you're using source-driven development, you can use branching, but definitely parallel development is a big advantage of this 2GP model. Okay, so you might be wondering, so we've been talking kind of a lot of theory and vocabulary, but what exactly does a package look like, or what does packaging look like? So we said with 2GP, right, we're using source-driven development, we're using the Salesforce CLI, which means we're using the Salesforce DX. And so what a package actually looks like, on the left-hand side of the screen, we're looking at a file that is in an SFDX project. And we're looking at a specific JSON file. So it's the sfdx-project.json file. And this comes with all of your SFDX projects when you create a new project. And this file is how we define what our package looks like, what it is, and also dependencies, which is a really critical, I think, concept to understand. It also allows us to define our dependencies. So if we start up at the top, we're looking at the different package directories that we have in this particular project. And then we're looking at the path for the code or the metadata that's included in our package lives. We're looking at the name of the package, which in this case is expense calculator, looking at the version name, which we can declare ourselves, and then looking at the version number. So here I can see that it's 1.2.0, which means it is the first first major release. The 2 is that minor release, so 1.2.0. So remember that O is where the patch would come if we're doing a patch. And then the .next is a little bit of what's referred to as syntactical sugar. It's a quick way essentially for us to increment. The system will increment every time we run a build of a package. It will increment this package for us with that next. So there's keywords that you can use in this second generation packaging model. You'll see the keyword next. And then at the very bottom, you'll see, or not the bottom, in sort of the middle of this screen, you'll see a latest where it says the version number. This is cool because not only does it allow you to like sort of increment your package, but you can see that we're actually looking at dependencies in the next section. And here we're saying that our package is dependent on another package called accounting logic. And we can see that we want the latest version. So the 0.2.0.latest, the latest build of that particular package. So it allows us to keep making sure that we're using the latest and greatest code. At the very bottom, you can see that the package aliases. So these are, so I can see that there's like a 04T. Remember we were talking about 04Ts. These are the package IDs on the right-hand side. And then the names, the package names are on the left-hand side. So that's how we're actually mapped. So we said like account logic, that's a package. The way that this code knows that what package we're talking about is that we have this package alias down at the bottom. Okay, so that's what a package config file or package directory looks like. And then what happens to actually build a package, or the flow that happens when you use the Salesforce CLI to build a package, is on this right image. So you can see that we use the CLI to actually build. There's like a build command that we would type into the terminal. And what happens is it will extract the information that we've referenced in this package directory, and it will actually run a build in a separate build org that we actually don't see. So there's like a build org up in the cloud that will put together the package that you've defined in this JSON file and all of the dependencies, so all of these other 04Ts, and it will try and essentially like run the code and make sure that it's going to work. And if it doesn't, it won't allow you to build that package. But if it's successful, then it will spit out essentially this 04T or this package that you can do stuff with, that you can install into a sandbox or Scratch org, or into, you know, publish on the App Exchange if it's a managed package. But this is sort of the flow of what's happening when you run that command in the CLI. Okay, so These are some more examples, it's a little small, more examples of packages. It just helped me. This is, I come from definitely an org-based development background. This helped me sort of think about what a package looks like. So an example of another package that you can actually like go look at and poke at in GitHub are the Trailhead, what's it called? It's the, what do they call it now? It's Trailhead apps, but it used to be like and I'm not thinking of the right word now, but it's the different like Dreamhouse and e-bikes, those like developer packages that exist that you can install in your org and play around with. Yes, bikes, sample apps. Thank you, Kelly. Yeah, that's the word I'm looking for. Sample apps. You can look at these sample apps because these are actually like packages. They actually are packages. So if I look at Dreamhouse, and this is small, but you can see again that there's a package called Dreamhouse. There's the version name and the version number. And what you can see at the bottom is that it's, there's aliases too. There's the Dreamhouse LWC, and it has its own little ID, and so it's the same structure of what we just looked at on the other screen. This Dreamhouse LWC has its own sfdx-project.json file, and so does, and you definitely can't see this, so apologies if it's so small. But what you can see here, if it were bigger down here, there's like a long list of 04T IDs, because what happens every time you build a new version of your package, you'll see a new entry in your project sfdx project.json file. You'll see like version.1.2. So you'll see the new 04T IDs that get generated, which is kind of cool. Okay, so those are just some examples of what they actually look like. But you might be wondering sort of, okay, well, I've heard theory kind of, and I now kind of know what a package file looks like and how it gets generated, but where do I start if I want to move from this org-based development model that I have? Maybe you're not using packages at all. How do you start to move in the direction of this source-based development model? So a great place to start, especially if you're an architect, is the Salesforce Well-Architected white papers, which again are on architect.salesforce.com. There's an entire section in the adaptable white paper that has guidance on how to improve the packageability of your solutions. So we're going to dive into some quick highlights from that white paper, because I think it really gives you a good sense of how to start to adopt a packaging mindset. So packageability, what does that mean? I'm quoting from Well-Architected here. It says that not every organization will be capable of supporting the infrastructure required to define, maintain, and develop effective packages, but achieving packageability should be the ultimate goal for nearly every Salesforce org. So that's what I sort of led with at the beginning of this webinar, that it's hard to do, but it's definitely worth the effort of trying to get to that ideal state or closer to that ideal state. And the way to start moving in this direction along this continuum is to think about two concepts. So the first is loose coupling, and the second is dependency management. So what does loose coupling mean? Well, I think a good way to think about it is to think of what is it not. So the opposite of loose coupling is a tightly coupled system, or tight coupling. And so characteristics of tightly coupled systems, you'll see on the left-hand side, there are single points of failure. So there you have like really brittle systems. So maybe you have like a sandbox that's really sensitive, and like you need to have it set up in this exact way with this exact data for your test to pass. And if not, if there's like some small change, then like everything's going to start breaking. Like your test won't pass, you can't deploy your code to production, and it's a whole mess. So which leads to the second sort of characteristic of a tightly coupled system, which is slow and unpredictable deployments. So like everything takes you forever to refresh your sandboxes. It takes you forever to run your tests. There's always like an unpredictable thing that happens, and it's, you need to have lots of extra time to do your cutovers. Also difficult and complex debugging and troubleshooting cycles. It can be really hard to isolate what exactly went wrong, because everything's all sort of mashed together in your org. And then also definitely issues with scale and performance. It's another characteristic of a tightly coupled system. So what can we do instead to move in this direction of loose coupling? On the right-hand side of the screen, you'll see some considerations that you can keep in mind as you start to look at separating your metadata into packages to achieve this state of loose coupling. So the things you should think about. You should be thinking about what customizations that you've made are data and which ones are metadata, because the only thing you can put into a package, the only thing that you can put into that popcorn container is metadata. You can't put data into a package. Also, you want to think about how packaging is going to impact your teams. So we talked about the fact that if you're using 2GP, which if you're entering into the packaging world for the first time, you should be using 2GP. I hope I made that argument successfully, but it requires familiarity with the Salesforce CLI. If you want to have all that really fancy automation, you want to be familiar with the CI/CD technology. So this means that there might be a steep learning curve. And if you have devs in-house, maybe they're going to love this direction you're moving in. But if you have maybe folks who are more familiar with low code and UI-based development things like change sets and all of that good stuff, it's going to be a steeper learning curve for those folks. So definitely you might be looking at how it's going to impact your team. Are you going to have to slow down velocity in the short term to increase velocity in the longer term? Speaking of velocity, you want to think about how your packaging is going to change environment strategies as well. So in a perfect world, in a package-driven development lifecycle, your early work that's happening maybe right now in a sandbox, like in a dev sandbox, that should be done in Scratchworks. It's easier and faster to spin up these orgs, and then it encourages good, or how do I say this? It discourages bad behavior because those orgs are ephemeral. So you can only have a Scratchwork for so long, and you can't like build up all this complex like data and logic and process because the org is going to go away. So it actually forces you to build in this modular pattern because it forces you to put everything in source control because the orgs just don't last long. It's actually a good thing. You also need to think about, from your environment strategy perspective, what are you going to do to make sure that you can have teams actually be able to use Scratchworks? So you need to make sure that you've enabled a dev hub, that you're using Scratchworks or you've enabled source tracking in sandboxes, so that you can maybe use sandboxes when you need to. And just really think about how those dependencies are going to impact your team. You also want to think about how package versions are going to relate to releases. There are some limitations when it comes to how often you can version your packages. So they're limited on a 24-hour rolling basis, like a lot of things are. And as a best practice, you only want to version a package when you are confident that none of the contents is going to need to change. So you don't want to like package stuff up and then be like, I'm going to add stuff to it tomorrow. You want to like be pretty confident that you have everything you need, you package it up, and you're going to then test it. So you also want to not allow development teams to, use the success or failure of a package as a test. Like you want to be doing other testing. You want to be definitely create tests for making sure that your code is working and all of that good stuff, but you do not want to necessarily use the package creation as a test itself. And then the final consideration for creating this loose coupling behavior is to think about what the ideal end state for you should be. So I had said that it's definitely not there can be a steep learning curve. You don't necessarily want to try and package up your entire org all at once or create 1 billion packages, because that can create a whole new set of problems, right? If you can't manage the packages that you're creating, you can create like an over modularized environment, which also might not be good. So the guidance here is to start with building and releasing a few versions of a single meaningful package. You can have stuff that's unpackaged and stuff that's packaged, especially with unlocked packages. So that's okay. So make sure that you start incrementally, that you're doing this in a way that you have a release cadence that's really serving your business well, and that you refactor your packages over time. And I think what I like in Well-Architected is that it says that the ideal package end state is subjective. So again, we're moving towards this version, this ideal state, but the ideal state for your packaging landscape is going to look different than someone else's ideal state, depending on the stuff that you have on hand and the maturity of your organization and the complexity of your organization. Okay, so that's the loose coupling. The other behavior or habit that you want to develop to have a more composable solution is called dependency management. I abbreviated it on the slide. So as you build dependency management into your solutions, you can consider two different strategies, two different sort of theoretical strategies that we've detailed in Well-Architected. And the first one is the concept of vertically structuring your packages or having vertical boundaries. And the second one is horizontal boundaries, or having that you'll see like here, we have like shared services. It's kind of hard to read, and a shared data model, but we have like different vertical packages for function A and function B. The other sort of hybrid model is vertical and horizontal dependency management. But all of this is to say is you should start thinking about how you are going to be structuring and grouping your units of metadata in your org to make it work for your business. So does it make sense to have completely separate stuff because you don't have shared data models or shared services? You want to keep everything separate because that's going to allow for the most stable artifact possible. Or do you have a bunch of shared stuff and it just makes sense to have shared packages and make sure that you have clear visibility into those dependencies? And this is important to think of upfront because the downstream effects that you have by choosing a vertical structure or a horizontal structure affects your how you're going to manage your repositories. Because again, we're talking about package 2GP, which is all based on source control. So if you have vertical package boundaries, you're going to most likely have multiple repositories, like we saw in the sample apps GitHub that we were looking at. Like there are multiple packages, right, for those different apps. And if you have a horizontal dependency management structure or boundaries, then you're going to more likely have what's called a mono repo or a single repository for all your code. And that has different, you have to think about these things up front because it's really important to structure your code and your repositories in a way that's going to support how you want to package up and work with your code in the long term. So loose coupling, dependency management, these are important things to keep in mind to develop that well-architected composable solution with packaging. But you might be wondering, okay, so great, I know some best practices, we've talked about the definitions, we've looked at a package, but how can I actually get started? So a practical approach to get started is to think about these three different models, and this is from Trailhead. I think it's a pretty good module on how to start thinking about organizing your metadata. In general, you want to make sure that you are, and this is from Well-Architected, not from Trailhead, but you should be thinking about your packages based on functional units of business-oriented logic. So you don't want to think about your packages like, I'm going to have a package for developer A and it's going to be package A, and developer B is going to have package B. Like, don't think about it in terms of like your development teams or your development process. You want to think of it in terms of how your business is going to use the functionality you're building. So with that in mind, there are these three different models that you can think about to get started. So one is app-based. So this is similar to what we were looking at in the sample apps gallery, where you create a package for the Dreamhouse app, right? But it's metadata that you're building, not necessarily that Salesforce is building for you to consume, but it's this idea of wrapping up an app like Dreamhouse into a package and doing it that way, app-based. Or you can use a customizations-based approach where You organize your unpackaged metadata for customizations and functionality in your production org based on the cloud that it's touching. So like a sales cloud customization package or a service cloud customization package. I don't love this as much just because, again, if you're thinking about business, orienting it to business capability, there might be business users who both use Sales Cloud and Service Cloud. So building those package boundaries when you know they might be crossed in the future is like a little, I don't know, maybe not the best way, but it's definitely a way to get started thinking about grouping stuff. Just like moving in this direction is what's important. Because by dividing up, and even if you don't package it, like dividing up how you think about your metadata is going to make it easier for you to like wrap your arms around the complexity of your org. And then the third model to get started is to think about a shared library. So that like horizontal model, right? So if you know that there's dependencies, you can use a package to organize a set of Apex classes or commonly used custom objects all together, and then sort of bringing all of we've talked about together back to the forefront. You can then construct dependencies. Remember how we saw that JSON file? You can construct dependencies on the common package so that you have this shared library that can be used by other packages as well. So that's definitely a good strategy for that horizontal model. And then you can mix and match. So like when you package or construct different packages for your org, you might have a shared package with those common things. And then you might have app-based package for business unit A and another package for business unit B. And the whole goal, again, of this is to have a more stable way to introduce change. So you can do a lot of development for business unit B, and like business unit A in their own package is not going to be disrupted. So that's the end game for all of this. Okay, and then I saw this in Trailhead the other day, and I think this is a really nice, this is sort of like, this is something I hadn't seen before. This is like a very, very practical approach to getting started working with unlocked packages if you were like not at all comfortable with the CLI. Well, that's a lie. You have to be a little comfortable with the CLI, but you don't have to be like super comfortable. So this allows you, following these steps, and if you're interested, if you like want to try to do this and you want me to see me do this, let me know, because maybe that could be a future video that I do. But essentially, you can get started with what's called an unmanaged package, which is, remember, 1GP. That's that first generation. The advantage of doing this is that it is org-based. So there's like a clickable interface. Like you can go into a Trailhead org and set up an unmanaged package, kind of like you're adding stuff to a change set. You just like add a customization. And the cool thing, like why would you want to do this? The cool thing about doing this is that when you, kind of similar to change sets, I think you can, like, you can tell I haven't done a change set in a while, but you can, through the UI, through the interface, if you add an Apex class or add a field to your unmanaged package, you can see the dependencies that are related to it by clicking a button that says like show dependencies. So this can be helpful to unearth like those connections of what you would need to include in a package or have as a package dependency. And once you have a nice unmanaged package, even just like a really simple one with a couple of things in it, you can turn that into a source structure, and then actually push that metadata to a Scratch org and ultimately package it up with the CLI. So you can start with like, hey, I don't really know my dependencies, but I'm just going to click around and add some stuff. You could then turn it into source format using the CLI, and then actually turn it into an unlocked package, which is that version that we want to be using in the future. So be kind of a cool way to like get your feet wet with unlocked packaging if you like kind of have no idea where to start. So I thought that was a pretty cool way to like start getting your hands dirty with all of this packaging stuff. Okay, so end of the day, we're like wrapping up on, we're coming up at the top of the hour. The message I definitely want to leave you with is to not be afraid to get started. So don't be afraid to get started. This is an area that I am like, I don't have a lot of on-the-job experience using packages, especially as a customer. I feel like a lot of customers don't, unless they have a very mature development lifecycle DevOps structure. Packaging is new to a lot of people. It does take, there's a kind of a steep learning curve if you've never used source-based development. But definitely don't be afraid to get started. Do some learning on Trailhead, poke around with unmanaged packages and maybe try and turn them into unlocked packages. And at the end of the day, I think the big takeaway for architects, whether you're going to actually use this in your real life or not, is to start to embrace a packaging mindset. Being aware of the dependencies between your metadata, knowing what is data and metadata like really clearly and how that can affect a lot of different things is really important. And understanding how your different business units use the different pieces in your org, even if it's just going to continue to be a happy soup org, is important. It's going to help you be a better architect. So definitely encourage you to start embracing this package-based mindset. And then in conclusion, kind of coming back to LBA and Ladies Be Architects in general, if you're not familiar with our website, that's where we'll post this video. It has a lot of other great content and videos. We're on Twitter, LinkedIn, and then the Architect Ohana Slack group is also a great place to do more learning and meet more architects and aspiring architects. And if you want to get involved more, if you want to do more than just follow on Twitter, we would love for you to participate. So come to our virtual study sessions, ask questions, share your thoughts, invite your friends, but also if you want to learn something and want to learn along with people, feel free to stretch yourself and volunteer to lead a study session. So if you are interested in that, definitely let us know. And I think with that, I will say thank you. And then if you have any questions, feel free to put them in the chat. I will probably stop recording here so we'll have a clean recording, but thank you so much for joining on a Wednesday night, Thursday morning, and I'll hang out here a little bit longer for some questions. So let me stop recording.